everyone, in this video we will be going over angle and triangle relationships. Our essential question for today is, how are angle relationships used to find missing angles? How are angle relationships used to find missing angles? Now you guys have been given a foldable and these have a bunch of geometry terms in them. However, as you can see, there are no pictures attached. So what we're going to be going over is all of these geometry terms, and you're going to be drawing in the pictures that represent those terms and definitions that are provided on that foldable. So first, let's go over some basic geometry terms that are probably going to be very familiar to you. So first, a point is a location on a plane or in space. You probably remember a point being represented on a coordinate plane, and when you would put that point, it might represent a certain x and y values, such as 1, 2, or -3, 4, and you would plot that point on that coordinate plane. A line is a line that extends forever in two directions, and it means that it has no endpoint on either side. It goes on forever and ever. And for a plane, I didn't really have a good picture of that, but basically imagine a flat surface, okay, and then it extends forever in all directions. Kind of like the table that you're on right now. It doesn't extend forever, but imagine if that table did, and that flat surface extended out in all directions forever and ever, and that would be a plane. All right, and a line segment is a line that has two endpoints. And so what that means is that it does have an endpoint and a beginning point. And so maybe the beginning is at A and the end is at B. And to write this on your paper, you'd write it as A, B, with a line over it, and that tells you that that is the line of A, B. And it starts at A and goes to B. Now, a ray is a little bit different. It's kind of like a combination of a line segment and a line because it does have an endpoint, but then it does also go on forever and ever in one direction. And I know it says two, but it's just one. Not like the band, just like the geometry term. And so when you write this, you would have A and B. You would have a line, just like before, but this time with an arrow. And that tells you that it's a ray. It's a line that has an endpoint and then goes forever in one direction. Now, intersecting lines are lines that intersect at a point. And so right here is where those lines intersect. And it could be more than two lines. You could even have another line that goes right through, and all of them are intersecting at, three lines are intersecting at one point. But intersecting lines are two lines that cross paths. Now, parallel lines are two lines that never intersect. And oftentimes when you are doing your math, you're going to see that represented by arrows on those lines. And so if you ever see arrows on the lines like that, that means that they're parallel and that they will never cross, so they will never intersect. Now, perpendicular lines do intersect, and they intersect to form an exact 90-degree angle. And that 90-degree angle is represented by this square right here. So whenever you see that square next to lines, you know that represents a 90-degree angle. And what's important to note about this too is then that makes all of these a 90-degree angle, because every line is 180 degrees, so 90 and 90 would make this one also 90 degrees. All right, now let's go over some specific terms to angles. Now, a vertex is a point where two or more straight lines meet. And you'll often see a vertex drawn with a half kind of circle, or as we saw before, that other one had the square that represented a 90-degree angle. But that just tells you that there's an angle there and that is the vertex. A transversal is a line that crosses at least two other lines. And so the transversal in this case would be this line right here. And it's a line that crosses two other lines. And it could be even more than that. I could have another line coming through here, and that would still be a transversal because there's one line cutting through those other lines. And finally, we have a straight angle, and this is a very easy angle. But anytime you see a straight line, that makes a 180-degree angle. Kind of like we were talking about before when we were looking at the perpendicular lines. Which it's not. There we go. The perpendicular lines back this way. This is a straight line, and if 90 is taken up, then 90 is left over for that side. And so a straight angle is 180 degrees. Now we also have a right angle, which we've talked about before, and that is where two lines form a 90-degree angle. And two lines form a 90-degree angle. That's represented by this little square, and that tells us that it's a 90-degree angle. Acute angles are two lines that form less than a 90-degree angle, so they are much smaller. And in the other way, the obtuse angle are two lines that form an angle greater than 90 degrees. Sometimes people remember it as acute angle, like it's small, so it's cute, and obtuse is large, so it's obtuse. So if that helps you remember, then awesome. So congruent angles are angles that have the exact same angle measurement. And for some reason, this did not show up. I'm not sure why the symbol didn't work, but the congruent symbol looks like an equal sign with kind of like a squiggly on top. And that means that ABD is congruent to EBC. And so when you follow these angles, you see A to B to D has the angle of 70. And then EBC, E to B to C, has an angle of 70 as well. And those are the same, so that means that they are congruent. Now, adjacent angles are angles that share a common side and vertex. So they share a common side and vertex. So it says ABD, so ABD, oops, that was really terrible drawing. So ABD, apparently I cannot draw on this. Anyways, ABD, there we go, is adjacent to DBE. So let's see how well I can draw. So that's saying those two are adjacent, and the reason that they can be adjacent is because of the fact that they share a vertex, so they share a point right here, and then they share this common line. Okay, so they share that common line. So those are adjacent, they're right next to each other. In the same way, we've got D, B, and E is also adjacent to E, B, and C. That side was much better. And they share a vertex and they share a common side. So that makes them adjacent. Now, things that would not be adjacent would be ABD is not adjacent to EBC. They may share a vertex right here, but they do not share a common side, so those are not adjacent. Corresponding angles are angles that are crossed by another line to form matching corners. So if I look at 1 and 5, that would be corresponding angles. So 1 and 5 are in the same place, but on different lines. So those are corresponding. In the same way, 2 and 6 would be corresponding. So 2 and 6 would be corresponding. And we've got 3 and 7. So as you can see, they're in the same location, just at on different lines. And finally, we'd also have 4 and 8 as corresponding. So 4 and 8. So and what's important about that is the idea that corresponding angles have the exact same angle measurement. So if 1 is 100, then 5 has to be 100. And if 2 is 80, then 6 has to be 80. And so corresponding angles are congruent. Now, vertical angles are angles that are across from each other. So 1 and 4 would be vertical angles because they're across from each other, and so would 5 and 8. And in the same way, 2 and 3 would be vertical angles, and 6 and 7 would be vertical angles because they are directly across from each other. Now, vertical angles, again, just the same as corresponding angles, are congruent. And so this means that they have the same measurement. So if 1 is 120 degrees, then 4 is 120 degrees. If 2 is 40 degrees, then 3 has to be 40 degrees. Complementary angles are two lines that add up to 90 degrees. So 30 degrees and 60 degrees creates 90 degrees. And supplementary angles are two lines that add up to make 180 degrees. So 180 degrees. One way that I remember this is because sometimes complementary and supplementary, those get confusing. I remember the C as, I went too far and it won't let me go back. There we go. So the C, complementary starts with the C, and there is a corner when you are talking about complementary angles. And with supplementary, it starts with an S, and we've got a straight line. So that's how I always remember it, because sometimes those can get confusing. All right, and some triangle terms, and then we're just about done with all our geometry terms. An equiangular triangle is a triangle with all equal, and I wrote sides, but it really should be angles. So all equal angles. And so in this triangle, all of the angles equal 60 degrees. Now, one important thing about triangles is that all triangles add up to 180 degrees on the inside. So 60 plus 60 plus 60 equals 180. An acute triangle is a triangle with all acute angles. So as you can see here, all the angles are less than 90 degrees. They still all add up to 180, but it's less than 90 degrees, so that makes an acute triangle. An obtuse triangle is a triangle that has one obtuse angle. And it's important to note that only when you have an obtuse triangle, only one angle can be obtuse. Because think about it, what if I tried to have two angles that were obtuse? So for instance, what if I had one that was 100, and then I tried to draw another one that was 100? Like, that's going to be a giant angle. Like that, even if I try that, when I connect them, it's not going to work. It's going to make a different shape. So you can never have more than one obtuse angle, especially because if you think about it, whatever that next angle, it's over 100 plus 100 is 200, which is bigger than the 180 that we need when we're solving and adding this side, or the angles of the triangle together. And last, a right triangle is a triangle that has one right angle. Again, you can't have more than one right angle. So imagine that I instead tried to make this into being a 90-degree angle up here, and I drew a straight line out. Well, if I made that a 90-degree angle, then the only way this can connect is to make a rectangle. So you can never have more than one 90-degree angle in a triangle. Now, equilateral triangles are triangles that have all equal sides, so maybe 8 inches, 8 inches, and 8 inches. And it's also important to note that when you have an equilateral triangle, all the angles will be the same too. So if you have an equilateral triangle, it's also going to be equiangular. Okay. Now, a scalene triangle is a triangle with no equal sides, so they're all different. For instance, like this one where it says 4, 8, and 10. None of the sides are the same, so they have no equal sides, which makes it a scalene triangle. And finally, an isosceles triangle is a triangle with two equal sides. So for instance, 6 and 6, those are two equal sides with one that is different. And if you have an isosceles triangle where the two sides are the same, then two of your angles will also be the same. All right, now let's look at some examples where we try to find the missing angles. So first, what if we had a problem like this? And it says find the value of x and angle ABD. So it says find the value of this x right here and angle A. And so that goes from here, angle A, B, and D. So they want us to find that angle right there. Now this is a complementary angle, and it has a 90-degree angle right here, which means we can set up an equation to solve this problem. And all we have to do is go, okay, whatever this is, plus the 60 will equal 90 degrees, because these two angles together equal 90 degrees. So all I end up doing is adding those two angles together and show that it equals 90 degrees. Now x plus 15 plus 60 can be simplified to x plus 75 equals 90. And when I subtract 75 from both sides, I get x equals 15. Now some people stop right here and they go, oh, okay, I'm done. I found my answer. Okay, but that's not exactly true. You just found out what x is, which is one of our answers, but we also need to find out what angle ABD is. So we know that x equals 15. Now we have to find angle ABD. And to do that, we just plug 15 back into x, and that gives us 30, because 15 plus 15 is 30. And that's really all you're doing to find the missing angle. Now on a straight angle, remember, a straight angle equals 180 degrees. So this time, we're trying to find the value of x, and we're also trying to find the value of DBC, and DBC is right here, D, B, and C. So we're trying to find x and DBC. Now these two angles, if we were to add those together, would equal 180. So all I show right here is that I'm going to add these two angles together, and they equal 180. Now 3x plus 2x is 5x, and 5 minus 10 is a negative 5. So now we're looking at more like multi-step equations. Now the opposite of subtracting 5 from both sides would be to add 5's to both sides. And I have 5x equals 185. And when I divide everything by 5, I get x equals 37. Now again, we found x, but we also have to find the angle of D, B, and C. And when I plug that in, you would get 2 times 37, and then you would subtract 10. And so it's actually a pretty easy problem. The thing that tends to confuse most people is that they forget to find that missing angle, or that they think that x equals that angle, when that is not the case. All right, these ones are one of my favorites because they're so easy. But find all the missing angles if angle 1 equals 120. You have to think back to some of those rules we talked to in the geometry terms. So if angle 1 is 120, what would angle 2 be? Well, angle 1 and angle 2 form a straight line. Okay, so if you look at it right here, this is a straight line. So if angle 1 is 120, what is left over for angle 2? Now a straight line makes 180 degrees. So if 120 of it's taken up, then all that we have left over is 60 degrees. And once you find this angle, the rest is all easy from here. Because if you look at 3, 3 is across from 2. And if you remember, that tells us that that's a vertical angle. Okay? And vertical angles are the exact same. So 3 is also 60. Now 4 is right across from 1, which makes it a vertical angle, and those are the same. So 4 is 120 degrees. And then on angle 5, now remember, the corresponding angles are angles that are congruent and are in the same location, just on different lines. And so angle 1 and angle 5 are congruent, which means that they have the same measurements. So if 1 is 120, then 5 is 120. And then on 6, that makes a straight line. So just like before, just like with 1 and 2, 6 is 60. And across from 6 is 7, which makes that also 60, because those are vertical angles. And across from 5 is 8, and since those are vertical angles, that's also 120 degrees. So as you can see, the transversal ones are very easy. They're a lot of fun because once you find out one of the missing angles, you can find out the rest very quickly. All right, and let's look at one complex problem. So this one says find the value of x and FOC. So let's find out where FOC is. We've got F, O, and C right there. And it tells us a lot of information. Okay, it tells us that FOE, so F to O to E, is x minus 6. And E and O and D is 3x plus 8. And that COB is 20. So there's a lot of information going on here. Now the first thing to do is, let's find out what x is. Now, as you can see, this is a 90-degree angle, right? And do you see how this is a straight angle? So if this is a straight angle, and this is 90 degrees, then this has to be 90 degrees on this side as well. Let's see if I can draw that. So this has to, apparently not, it has to be 90 degrees as well. And so what that means is that FOE, so FOE, and EOD equal 90. So I just took these two equations and said, oh, those have to equal 90, so I'm going to add them together. Now x plus 3x is 4x, negative 6 plus 8 is 2, and I can subtract 2 from both sides, and I get 4x equals 88. And when I divide by 4 on both sides, x equals 22. So we found the value of x, which is important. And so that doesn't tell us the actual angles. Now, if we want to find the angles, we plug these numbers in. So FOE was x minus 6. Okay? So all I do is plug in 22, and I get 22 minus 6 is 16. So right here, I've got 22 degrees. And I'm having a hard time drawing. Let's see. 22 degrees right there. Now, EOD was 3x plus 8, and when I plug 22 into that, I end up getting 74. Okay, so I found 74. So that's 74 degrees. Now remember, the last thing we need to find is F, O, and C. So we have to figure out what is this angle right here. And it doesn't mean it's the exact same as this one. It might be off slightly. And it probably is because over here we found out that COB, so COB is 20 degrees. Okay. Now, what's this missing part? If this is 20 degrees, then what does this have to be if it forms a 90-degree angle? Well, then we know that has to make 70 degrees. Okay. And so we found out that this is 70 degrees, so we found the whole top part. And now we just need to add these three numbers together to get our FOC angle. And so angle FOC, when you add all those together, would make 160. Make sense? All right. All right, and find the missing angle. All right, so when you're looking at finding the missing angle of this one, you have to remember that the angles all add up to 180 degrees. So the angles all add up to 180 degrees. And so all we have to do is put 55 plus 82 plus x, because that's what's going to be our missing angle, and solve that equation. So 55 plus 82 is 137. And when I subtract 137 from both sides, I get x equals 88. And that's it. So those problems are really easy. And last example, and this one looks probably pretty scary. But these ones are really fun because it's kind of like you're figuring out what's missing. And so all you have to do is we have to figure out only what x is. That's all they're asking. But to find out what x is, we're actually going to have to find out all these missing angles that you don't see written. So let's start up here with 45. And I like that to start with because across from 45 is what's called a vertical angle. Remember that from our angles? So across from 45 would also be another angle that is 45 degrees. Okay, so we found that angle. Now let's look right here. We've got the shape of a triangle. Okay, so we've got the shape of a triangle right here, but we're missing one angle, right? And we know that triangles add up to 180 degrees. So if I were to do 180 degrees minus 60 minus 45, I would find out that the missing angle is 75. So not so bad so far, right? You're just looking for triangles and vertical angles and straight angles and trying to find out what's missing. Now here, our next angle that's missing is right over here. And as you can see now, we're looking at this as a straight line. So we've got a straight line right here. And a straight line, again, adds up to 180 degrees. Now, if I were to take 180 degrees and subtract that from 75 and 68, my missing angle would be 37. And again, now we've got another triangle over here. So I've got a triangle here, and one angle is 100, one angle is 37, and then I've got a missing angle that I do not know. So the question is, what is this missing angle over here? Right? So what's that missing angle? Well, if I were to do 180 minus 100 and minus 37, I find out that that missing angle is 43 degrees. And then the very last thing that we're going to look at is that, again, this is a straight line, and straight lines add up to 180 degrees. Now, if 43 degrees has already been taken up right here, what is left over is 137. And that's it. That is how you find that missing angle. Now, there are no practice problems for this set of notes, but if you have any questions, let me know and we can go over to class. Thanks.